One of my crowning achievements was writing a BASIC compiler in BASIC on the TRS-80.
I could type in Hunt the Wumpus right now. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Al Williams.
This is episode 354, Firearms, Skydiving, and Dumpster Diving. This week in the news, close to the hearts of many 3D printer users, there's a Washington state bill which aims to prevent people from 3D printing gun parts. I mean, nobody wants unlicensed guns out there, and maybe it is possible to 3D print some parts to be useful to make an untraceable gun. So I guess the goals of this proposed legislation are not entirely crazy. It's just that I think it's entirely impossible, or at least partly impossible. And that was kind of the take that Maya had when she wrote this up. It's actually worth looking at to go see how the bill itself is laid out. Equipped with blocking features means a three-dimensional printer has integrated software controls process that deploys a firearms blueprint detection algorithm such that those features identify and reject print requests for firearms or illegal firearm parts. So they're trying to have either your printer or your slicer tell you, sorry, you can't print this. And how they're going to force you to use any particular slicer or printer or whatever, I don't know. Moreover, it's a technically really difficult problem. And I think that's what I thought was interesting. It is my belief that the people writing the law have no idea what they're talking about here. They just proposed a technology and they're hoping that it can be implemented. But it got me thinking about how you would actually do it. And the part that gets interesting is that the very bottom of the legislation, they propose that the Attorney General shall create and maintain a database of firearms blueprint files and illegal firearm parts blueprint files, et cetera, et cetera. And that's when I started to think, hey, maybe this is possible. Maybe you could do some kind of 3D shape matching thing to see if you are printing out an illegal part. And then I'm like, wait, maybe this isn't totally crazy. What do you think?
I don't know. I think there's a lot of problems with it, right? But let's just focus on the technical. I mean, this is Hackaday.
That's what I'm doing.
I think if you told me we're going to produce a list of things you're not supposed to print, and then we'll, do a hash on them or something, and there's a database. I mean, kind of like you do a secure certificate, right? You go, oh, that certificate's bad, and then everybody goes, oh, no, I can't use that certificate. I could see that's technically feasible, other than immediately people will hack around that, and that would stop people from accidentally printing guns, perhaps, but they don't think that's going to stop anybody that actually wants to. The problem is, it's like virus detection. If all you do is look for people's viruses that you know about, then you're vulnerable to the viruses you don't know about. A human could look at something and go, ooh, I think that's a gun, and probably be right. I guess you could throw AI at it, because that's what you throw at everything now. But I don't believe that the same AI that can't figure out that there's no seahorse emoji is going to 100% reliably pick all guns and not pick non-guns. I'm always really amused at the whole idea of this, though, simply because I guess it's like in the old days with if you made a mixtape for your girlfriend, the record companies didn't actually care about that because it was a crappy cassette tape copy and you were just making one of them. But when you can make digital copies that are perfect, now they care about them, right? And you're just spreading them out to millions of people you don't know. They're very interested in that. It seems like this is the same kind of thing. If I really want to make a gun, I don't have to have a 3D printer to do that, right? Guns predate 3D printers by at least a few years. The difference is I have to have a lot of skill to make a workable gun with a lathe and a drill press and, whatever else you need to make a gun. With a 3D printer, I guess the idea is I could just download something I don't understand, push a button, and, plastic gun comes out.
And the false positives are going to be fun too, right? Like all the things I print out that probably accidentally look like, the receiver part that's supposed to have the serial number on it or whatever. Like, I don't even know what that looks like, honestly, but...
Well, there's probably also a lot of gun-shaped things that people make that aren't guns, but...
Or that are airsoft guns or Nerf guns or prop guns because, they want to be Han Solo for Halloween. Yeah, it's going to be tricky. Yeah. It's going to be very tricky. There's no possible segue. How do you go from guns to what's that sound?
You could say, are you ready for what's that sound? And I'd say, shoot.
This is a journey into sound.
What's that sound?
What's that sound?
This week is a pick a winner week, which means everybody wrote in last week, took their best guesses at the sound. Al, do you want to give it a try?
I actually listened to it right before we started.
Shocked. I'm
And
shocked.
the original thing I thought was, oh, it sounds kind of like, I'm not a gamer like Nardi, right? So I thought, and I loved his voiceover on the podcast where he was, ooh, yeah, I'm digging it. It sounds like Zelda. I went to YouTube and looked up Zelda, and it was like, yeah, it's kind of like Zelda, but it obviously wasn't Zelda. And that's the best I got, is some distant cousin of Zelda playing music when you open the treasure chest or something.
It's basically the right era. It's the video game Gyrus, which was what? It was kind of, it came on after Tempest. You're flying a spaceship and you're going down essentially a tube. It had a spinny wheel to rotate it around there, and then you shoot at asteroids and spaceships and things that come out at you. It's a great game, actually. If you haven't played Gyrus, go play it. But that soundtrack, I picked it because I love that soundtrack. It is such, it's, first of all, it's Bach's Toccata and Fugue, and second, it's a baller 8-bit version of it. It's just so great. It's running the whole time you're playing the game on a fairly long loop, and yeah, you'll just get into the zone. Even hearing it makes me think of, flying that funny spaceship around.
I've never heard of that video game, which is not terribly shocking, but
So good. A lot of people wrote in, actually. We got how many? 24 people wrote in, and 19 of them got it right. All the other guesses were, of course, kind of period video games. So good job, everybody. My favorite answer probably is Colonel Panic's 2 Warps to Neptune, which is one of the things that shows up on the screen. In one word, Gyrus. In 2 words, also Gyrus. That's also correct. Anyway, congratulations to everyone who got it right. That was such a great game. So many people were like, this is my favorite game. Apparently, 1983 arcade game. I was playing it on the RetroPie with my son a few years back, actually. It holds up even to this day. 19 people got it right. I got a 20-sided die here. If it comes up 20, I win. Oh, Jesus.
yeah, this isn't suspicious at all, Elliot. Not suspicious at all.
What are the chances? Okay, if it comes up 20, I roll
I'm going to
again.
guess 1 in 20, but I'm not a statistician, so take that with a grain of salt.
Approximately 5%. If it comes up 20, I'll roll again. There. Oh, geez, now it's a 1. Weird die. Congratulations, SpyBob42. You are the first answer and our winner. Main theme from Gyrus, one of the most underrated video games of all time. Hell yeah. I'll shoot you an email, get your address, and get you a Hackaday podcast t-shirt. Everyone else, stay tuned next week. We'll do it again. All right, well, let's start off the hacks. My first pick this week is TimeSync Studios' awesome video, How to Use Tiny Open Loop Actuators for a Living Mirror. This is even more than a living mirror. This is he's built an array of 128 mirror segments, all of them on little 2D kinematic mounts, basically. So they can aim the reflected light beam in both the X and the Y direction. And his demo is he's got it sitting in a courtyard, sun's shining on it, and it's making different shapes with all the kind of pixels that it can steer around. It's a really great idea until you start thinking about how to build this thing. And so, 128 kinematic mounts. Well, okay. It's supported on a tripod, 1 solid piece, and then 2 that can move up and down. So you have to have some kind of a linear actuator for the 2 moving pieces. And, when the Y one moves down, it tilts in that direction. When the X one moves down, it tilts in that direction. Pretty easy to conceive of, but then of course you need ball joints for all of those. Here he actually kind of cleverly uses magnets stuck against a piece of metal. So it's not a perfect ball joint, but as long as you've kind of rounded the bolt over, it's probably close enough. He starts off using the kind of 28B whatever stepper motors, those cheap geared steppers that you can get for kind of $1 each. So if you're building 128 of these, price matters. But they've got a lot of slop in them and they're big and they've got a lot of other problems. He finally, through some hardcore Alibaba shopping, settles on a little linear actuator that was used in a cell phone to flip up a selfie camera. And these are available even cheaper, especially if you buy a whole bunch of them. I think they're like new old stock parts. And he does mention that if you like troll around in Alibaba, you can find fantastic small linear actuators for dirt cheap. Just buy a whole bunch of them and see what you do. And that's kind of the motor side of this project, except that they have a weird custom flat flex connector on them, and he had to make little adapter boards for those. Then he has to figure out how to home the things, and how are you going to home 128 motors? Well, he just runs them all the way to the limit and lets them bang up against the limit and then figures they're not that torquey that they're going to rip themselves apart. So drives them against the limit, calls that zero. And then the rest is a little bit of math and a lot of motor driving. That's a really cool project. I think there are a lot of other things you could do. My first thought was I wonder if he could do like a webcam to do the homing. So instead of like homing them, you just figure out where each mirror is pointing by, wiggling it around in a particular pattern and using some computer vision thing. But now that I say it out loud, that's actually super hard. It's easier to just run the motors all the way over.
Yeah, I wonder if you could, if you could like have a light sensor and just like swipe each one of them until the light hits it or something. I don't know. Yeah, it seems like there'd be something. My reaction to this, I had two reactions to this. One is it was a macro scale DLP chip because I mean that's how DLP works, and I've actually got a DLP chip somewhere on my desk that I use sometimes when I'm showing kids things under the microscope. It's kind of fun to look at.
Yeah.
But from an economic standpoint, it got me thinking about, okay, did he really get those parts cheap because they're in cell phones and the economy of scale has driven them down that far? Because I think there is some things like that, right? That they'd be super expensive if you sold 10,000 of them a year, but because you're making 20 million of them a year, they're super cheap. Or old people like me will remember polypacks, right? Polypacks made a business out of going to these factories and saying, hey, you ran a big reel of transistors into the radio you were building. And after you made your 5,000 radios, there were 75 transistors left on the reel, which you will no longer use because you're not going to spin up for 75. So sell them to us for virtually nothing. We'll put them in plastic bags, poly packs, and sell them. So I wonder if that's where the 40-cent actuators are coming up, is you make your million cell phones and then you've got, 700 motors left on the reel. So you think, oh, well, what am I going to do with these? And you put them on Alibaba and sell them for 40 cents a piece. Or if it's really that they've gotten that cheap. I don't know.
I'm nearly 100% sure it's the former. I think they're absolutely like, we made millions of these for the cell phone. We didn't make that many cell phones here. And like somebody finds this and is like, oh, I can sell these.
Yeah.
It's true that there are tons and tons of these and similar actuators. I've done the same looking. Every CD drive, every, small electric thing that needs just a little bit of movement has one. And apparently everybody designs their own. And so there must be millions and millions of these surplus out there, but they're all different, right? And so that's kind of the problem on an industrial scale, but it's awesome if you're on the hacker scale where you need, a few hundred of these funny little things and you're willing to put the time in to figure out how to drive them.
Yeah, so I never really thought about that until I read this, that, maybe Alibaba is the polypacks of our day. I don't know.
Totally is. A couple years ago, it was all the rage to use those old CRT screens from Watchmen. They were kicking around. I think you can still get one of those for like $20, which is crazy for a little flat, weird shaped CRT screen. Until we used them all up. There were the BlackBerry keyboards, new old stock. Certainly budget because they were off of a production run, right? Yeah, great place to shop for random stuff if you need it. Although, as he points out, the search on Alibaba is just soul killing. If you're actually looking for something, God save you.
Well, I went looking for polypacks advertisements, and I liked the description of one of their kits. It was like CMOS ICs deliberately thrown in barrels so we can't test them. 60 for $1.98. How good? Who knows? Who cares?
Oh, good Lord.
If you get 60 for less than $2, I guess you can accept if half of them are bad, I guess. I don't know.
Oh, that's hilarious.
That's just a different time, it really is.
So I think a lot of people in the comments were like, wow, this is a crazy project because it's so many little precision parts. And I agree with that. Like it's 128 times making something kind of difficult, and that has its own certain effect. But it also totally reminded me of the wooden mirror. This was a also a DLP style hack. In fact, even more DLP because the mirrors in DLPs, they just go on off. They don't actually like they're pixels, right? They just
Hmm.
flip out of the way when they don't want to reflect light and they flip back into their spot when they do. This one's actually like, steerable in that one axis and then steerable in the other axis too. So it's fancier than the DLP. The wooden mirror is kind of much more along the DLP line. They just flip in one axis and you shine light on it so they reflect more or less light back at you, and it uses kind of that reflected light to make brighter and darker pixels. The coolest thing about it in the way it's a mirror is that it's got a little camera in the center, and so it's making the display flip around as you move around in front of it. It's a fantastic piece of art done by Daniel Rosen. We wrote that up on Hackaday back in 2016, 10 years ago. Someone found his website where he talks about making it, so you should go check both of those out. Links in the show notes.
My first pick this week was from Ray, I guess Open Sprinkler, and it's a guide for using triacs for switching AC. And I always think there's all these kind of forgotten stepchildren of semiconductor devices, right? Everybody knows we got bipolar transistors, you got FETs, and then of course you have all the big macro things in ICs. But there's all these other ones. There's triacs and diacs, and I think there's been biacs, and there's all of course some of that's marketing. Oh, I'm going to have the VXFET, okay, whatever. But the triacs are actually a really interesting device that allows you to switch AC, which it's really interesting that we don't have a lot of options in that area. You have relays, of course, which will switch anything, well, subject to their contact material and everything else, but at least in theory could switch anything. But from a semiconductor device, most of them want to switch the ground or the positive side, and yet almost all of us, the electricity we have available in our walls is not like that, despite Edison's best efforts. So you've got AC coming in. How do you switch it? Well, relay or these things. I don't think you see this as much as you used to, and it's because you really do, but they've been kind of monolithically jammed into things that we call solid state relays, and it kind of takes care of it for you, and it acts like a relay, but it doesn't have any moving parts. I still think it's a good thing to know about stuff like this. I think it's interesting to work through, especially if you dive into how it works at the semiconductor level. That's really interesting. There's still nothing wrong with doing it this way. A sprinkler system, of course, would be a really crummy place to have a real relay because it's, probably subject to being outdoors and wet and all these other things. So sure, you could use a solid state relay, or you could just roll your own with the triac. A lot of classic projects use triacs. The one when I was a kid you always saw was like a drill speed controller, because you can basically pick how much of the AC waveform cycle gets through and how much gets cut out. That also makes light dimmers, which you still see a lot of that, or the ubiquitous soldering iron heater control. Back when none of us actually had control of our soldering iron's heat, you would put a triac light dimmer in it and say, okay, I want 50% of whatever the top temperature was, and maybe you got that. Just kind of reminded me of a lot of those things. It's a good write-up. If you've not got your feet wet with triacs, it's a good one, good place to start.
There's one of the two of them, and it might be the silicon controlled rectifier, or is it the triac that turns off every time the AC waveform goes through zero? So you have to turn it back on again. When the current is removed, the triac remains on as long as the current flowing between MT1 and MT2 exceeds a certain threshold called the holding current. When used with AC, the triac naturally turns off near each zero crossing when the load current falls below this threshold. This explains why if you use a triac to switch DC current, it will only turn on but won't be able to turn off unless you unplug the power. That's awesome. Yeah, so they latch on until the voltage goes across zero. And I guess the dimming is turn them back on when you get to a certain part of the phase in the AC waveform that's going through there. So you if you want it to be on half the time, you wait until the AC waveform's at its peak and then you turn it on, and then it turns itself off when it goes down through zero again. And then when it gets to its trough, you turn it back on, and
Yep.
et cetera, et cetera. So you get this kind of weird, I don't know what, peaky, weird, halfway rectified on-offy signal.
Well, it's 50% PWM, right?
Yeah, but it's a 50% sinusoidal PWM. But yeah,
Yes.
totally. And it's chopped up into two quarters.
There's so many. We should have a series of, bizarro semiconductor devices. I mean, there's the programmable unijunction transistor and tunnel diodes
Yeah,
and
right.
the
Yeah.
Saki diodes and hot carrier diodes. And so I think a lot of those, though, it's kind of hard to get now because nobody
Yeah,
cares. I
most
mean,
of those.
nobody's really buying a lot of that stuff, I think.
Well, next up from me, Aurora Tech has a great video review of a continuous printing mod for the Bamboo A1 Mini. It's the Qi2 plate cycler, I guess. And this is basically a copy of a swap mod kit, if any of these mean anything to you. Basically, what it is it's got a spring-loaded stack of printing plates and a little lip on them that the moving 3D printer bed catches onto, pulls them into use, and then there's another little lever that lifts them up and it can push them off. It's a really slick system, and Aurora Tech points out it's a variant on something that we've seen a bunch of different variants on, and the one she's using seems pretty good. They're all kind of cheap. I was surprised by how little they want for these kits. They're all in the kind of $50 to $100 range, basically, for something that would, at least in principle, completely automate 3D printing on your printer, like make it entirely hands off. Anyway, I don't know if you want one of these. Like, she has one reliability issue with it, which sounds a little bit scary, but everybody has 3D printers mess up on them at one point in time or another. It just looks like a really cool system. I'd never seen it. I'm not in the market for an infinite 3D printer bed. It looks like a cool idea if you have a whole bunch of parts, or in the case of the Bamboo A1 Mini, just a small printer. And so you want to do multiples, you pretty much have to do a bunch of parts and then switch the bed out, do a bunch more, and then switch the bed out. So I think for that, it also makes sense. It kind of multiplies what limited bed space you got.
Yeah, I've seen systems like this before, and of course, we've also seen the conveyor belt systems and things like
Yeah.
that. I guess I'm just not advanced enough because I generally don't print stuff that needs to run, 24/7. And I'm thinking if you really were building a factory and this was important to your business, you could either hire a high school kid to stand there and when it stops, take the plate off, dump it, and put the plate back on, or, maybe buy a bigger, better printer. I'm not sure this is
Yeah.
the industrial strength printer that I want for that job. Now, as a piece of, project, oh, it's great, right? It's awesome. I'm very impressed. I got to tell you, I'm not a real super strong mechanical guy, as I frequently mention. And I'm always impressed at the innovative ways people come up with using the printer's motion to do different things. And I think this does that as well, right? The printer, you have to have some G code in there that makes
Yeah.
the thing move a certain way, and that's what pops the plate. I've got a flash forge over here, and I'm sure it's not the only one that does that. And if you move the head to a certain place, it makes the cutter poker pop out, and then the head basically runs itself into that poker to cut the filament. So, then when it moves away, the poker goes back into its recessed cubby, so it's not sticking out all the time. Years back, we did an article on a 3D printer color system that actually used like markers, and the markers were up at the top in a 3D printed tray. The printer, to switch the markers, would go up, grab the marker, lift it up, pull it out through a channel,
Right?
do the drawing with it,
Crazy.
and then come back and then put it back through the channel, drop it, and it would, stick again. And so that was all, there was no actual extra mechanical parts. It was just print this tray that can switch out these color heads, no mechanics, no motor, no anything, just because you already have all the motors and sensors you need built into the 3D printer. So this reminded me of that a little bit. I always think people who can think that up from scratch are pretty smart, and I was very impressed with it. I just, like you say, I don't think I want one.
Yeah, totally. I love that about this one too. It's like you've got a machine that's got a whole bunch of motors in it and can move arbitrarily. You just have to kind of choreograph that to do these extra functions. And I do think that's hilarious. The first printer I remember doing something like this, it must have been on Hackaday. It had a power switch at the very highest part. And so it would turn itself off when it was done with a job by just like going over into the corner, going all the way up and like physically flipping with the print head like a power switch that was mounted there.
That just seems like a take on the useless box kits, right? You've seen those where you
Yeah,
turn the
right?
switch on and the hand comes out and turns the switch off.
It's totally that, except it's putting it to use.
Think of how lucky you are that you didn't have to do a story about a bamboo lab printer while Nardi was your co-host. So
Yeah, well, Aurora Labs would agree with Nardi on this one a little bit because she does go off into a little bit of a rant about how the closed source nature of their printers makes it difficult to integrate with third-party kits like this. And actually, she runs into a little problem. So there's a tiny bit of that what I would call the usual grinding of gears trying to make things work with a closed source ecosystem.
my next hack is probably I probably picked it because I watched Star Trek as a kid, or as an
As a
adult. I guess that's
quote,
I
as
guess
a
I should.
kid, end
Yeah, I was
quote.
gonna say perhaps, but when I watched Star Trek as a kid, so this is electron impressions, and it's accurately aiming audio with an ultrasonic array. The idea is you want to project a narrow beam of sound towards a target. I'm not sure what the real use case is. According to the post, it was like, well, if you want to shout at somebody across a crowded room, and we could use those at the SuperCon, right? You want to, you see you over there by the food, and I'm over there by the soldering challenge. It's hard to yell, Elliot, Elliot. If you could do that, that would be great. The reason I bring Star Trek into this, other than I just like to bring Star Trek into everything, is, the aliens of the week always had some kind of ultrasonic thing that could knock you out or make you do things you didn't want to do, or there was always some idea of projecting ultrasonic energy somewhere, and I just kind of reminded me of that. Not to mention, it kind of looks like a ray gun, right? So I think it's I don't think it's a bad Rorschach test to think of Star Trek when you come on this. Is there any other value to this? I don't know. Interesting that you have directional speakers. And I mean, we see some of that like in museums, right? I'm sure you've been in a museum where there's like this cool plastic dome over your head. And while you're standing there, you can hear the audio for that exhibit. But when you step, a foot away, you don't hear it anymore. I think that's a pretty cool technology. And this kind of reminded me of that. The other thing it reminded me of was the old technology that we've written about before when they didn't have radar and they had the big giant parabolic dishes on the beach, so you would go stand in front of them and see if you could hear enemy bombers heading over the channel or whatever.
I've seen this hack before, and I don't know if it's the demo in the video here. It sounds a little bit rough, but I've seen this done with much more fidelity, and maybe we should go look around Hackaday and see if we can find it. The circuit's easier than you think. It's an array of ultrasonic transducers, but to make them put out as, quote, focused a beam as you can, you actually just want to have them all in phase. So it's not like you have to do any crazy beam shaping as long as you're not trying to steer the thing around. You actually just have them all run in phase with each other and spit the, kind of this wave of ultrasonic out. Really, really fun. I was at a Chaos Communication Congress, actually. I was walking by and someone was rickrolling with one of these things. So you're walking along, you don't hear anything, bam, all of a sudden you do hear it, and then you take another couple steps and you don't anymore. And, everybody walking through, of course, pauses halfway through and it's like, what? And everybody takes a step back, back into the spot. It's pretty funny. The question about how they work is still, I don't know 100% the answer. They're definitely ultrasonic transducers, and you kind of put the audio signal on them like you would amplitude modulate a radio carrier. When these then hit something, I absolutely know that it works. If you put a surface in the way and reflect off of that, it actually kind of makes the surface vibrate at the audio rate, right? It does the demodulation that way. And you can absolutely hear it coming off of, say, a piece of paper you hold up in the air. And that's a sweet effect. I'm not sure if when you walk by, it isn't demodulating off your skull or something.
The post said it's in the air. Yeah.
The person claims that it's demodulating in the air. Yeah, exactly. And I don't know if that's right. My personal experience of it, having put my own head in one of these, is it really feels like it's demodulating on my own head. And that makes maybe a little more sense to me. Like, how would it know at which part of the air to demodulate, in the 3D throw of the beam.
Yeah, I don't know. I wondered that myself. It's the Logan's Run guns where there's a flame at one end and a flame at the other, and it just happens to be that the flame hits the person, right? So it's like,
Yeah, yeah, yeah.
even that's a little more explainable than that. But even if it were focused, if you said, well, it's where the two ultrasonic beams converge, but I don't think those transducers are that directional, nor do I
No.
think they're focusing in any way. It looks like they're just in parallel, so I don't think that could be the answer.
Yeah, it's just constructive destructive interference, right? And so you put the two of them next to each other and they push out the same and it adds constructively in the middle and then, as you go out to the fringes, they're out of phase with each other and it cancels and then doesn't cancel and then cancels and doesn't cancel. There's all these funny nodes. But then if you have enough of them, all the funny nodes kind of wash out and you really only get the strong beam. I think there's more to the physics here than the person implementing this project understands, or maybe even than I understand.
Or me. I will go.
Yeah, exactly.
I don't want to.
That's
I
what
don't
I
want
just
to
said.
oversell that one.
That's what I just said. Well, anyway, like I said, we've seen phased array things like this a bunch. I'll throw a whole bunch of links for you in the show notes, both kind of simple builds like this, and then the absolutely craziest one where you do actually try to change the phase and steer the beam around. Alex Toussaint did one of those, and then he gave a talk on it at SuperCon. It's both the hack and the talk are absolutely marvelous. I'll throw all of these links for you in the show notes. Well, my last hack this week is definitely in the doing it because it's cool category. Ed Musa has built a self-powered top which spins for 2 hours and a little bit. The self-powered, of course, is the trick. You can't really build a top. I mean, I guess you could build an absolutely gigantic top and spin it super fast. And maybe with a lot of engineering, maybe if you put it in a vacuum, you could get it to spin for 2 hours. But it's easier to just throw some batteries, a microcontroller, and a brushless DC motor in there and cheat. And that's what he does here in this video. What's fun about this video is it walks through his kind of brainstorming process and the first couple iterations on it, and it ends up with the basically finished product. At first, he thought he was going to do it by building essentially a reaction wheel. So you accelerate something rotationally, and then whatever is holding it wants to spin in the opposite direction. And he's like, oh, so I'll do a reaction wheel. But then once it spins up to speed, there's no more force left. And in fact, then if it slows down at all, it puts the torque in the opposite direction, slowing your top down. So that's not going to work. His first thought was to get a bearing that has a ratchet in it. So he could torque down and it would fight against the ratchet, and then he could torque up and it would spin faster, and then torque down and fight against the ratchet. This ended up being, as it sounds, not only over complex, but lossy and loud. Not what you want if you want a top that spins efficiently on a small battery for multiple hours. The solution he comes up with is to just put kind of an eccentric weight in there and spin that around. So the top is actually always wobbling a little bit. It's basically like a vibrating motor inside the top, like the one in your cell phone, right? Where you've got a motor with a weight that's off center and it goes zzz and it spins. The top is doing the same thing. And so the gimmick here is you get the rate of the spin just fast enough that it's always kind of falling into the weight a little bit as it spins around. And that makes the top keep spinning as it goes on. He, of course, overthinks this as well and is like, oh, I'll try all sorts of clever control algorithms and I'll figure out an optimal fast, slow system. And nothing ends up being better than just running the motor at a constant speed. So in the end, he just settles down to, spin the motor up, give the top a spin, and then off you go. There's a lot of clever things in the build here. The plans aren't open. You can give him money on his Patreon if you want to get them. But, it's the idea that's clever, and you can basically figure that all out from the video. What I really like is he puts a whole bunch of extra drill holes into the 3D printed body so that he can then mount screws to balance it after the fact, because he's got an eccentric weight, and then he's got the battery, and then he's got the microcontroller, and they're kind of all located inside this thing that's supposed to balance like a top, right? So how do you balance it? The answer is by adding a whole bunch of different size screws into a whole bunch of different holes until the weights even out. Pretty clever design there. Is this something you absolutely need? I mean, he claims it saves him a lot of time because he used to have to spin his top every 30 seconds or so, and now he just spins it once every 2 hours. So it's a huge productivity boost in all the typing you can get done between top spinning.
That's a first world problem, right?
That is a made up problem. All of this whole damn thing is the hammer that he invented to drive the nail he has. But that's fine by me.
I want the late night commercial, right? Spending too much time spinning your top, you need top spinner. So yeah, this was an interesting project. I mean, of course, obviously reminds you of Inception with the clock spinning and the dream and all that. But
Right.
I mean, I was trying to think though, if there was anything that actually, if there was some way you might actually say, oh wait, this could be practical. Like, I don't know. And I mean, this is total BS, but I'm thinking, well, what if you made like you were making a disk drive and you wanted it to be able to spin long enough that when power went down, you could still, you could have a battery and it's still spinning for enough time to finish
Right.
writing before you finally click off or whatever. I couldn't come up with anything better than that, and I'll admit that's pretty lame even on the face of it. I'm sure there's a better way to do that, but it's still pretty cool, and I also thought it was relatively small for what it was. I was pretty impressed
Yeah.
with the size of it. I don't think I could have made that small, even though, if you look at the pictures, it's not teeny tiny, but it still seems like it's relatively small.
For what it's got going on in there, it's pretty small. I agree.
Yeah.
This would be the worst thing to put in your hard drive because it really relies on the top not being level. It has to, process around a little bit, and the spinning weight has to like drive it into its leaning over and then keep pushing it around. It's wobbling all the time at the frequency of whatever that motor is. So this would be trying to read or write data to that spinning platter that would have to be on a loose bearing and wobbling around.
I didn't
all the
say it was a
time.
good idea. I say it was the
I'm
best I could think
going,
of. So yeah.
yeah, right? No, I don't think there's I don't think there's an application for this one. I don't think there needs to be.
Maybe make your beanie propeller spin around for longer. Maybe that's the. See,
Self-spinning
now we're
beanie
talking
propeller.
practical. Now we're talking practical. Well, my last pick this week is from J.B. Crawford, who had a really, really meticulously comprehensive post about the modern air traffic control system. You might not want to read this before you get on a plane, because it's one of those things. It's like sausage. You really don't want to know. It's. I love the movie Pushing 10, where the line where the guy he's an air traffic controller, and he finally figures out whatever the central mystery of the movie is, and he tells the flight attendant, he says, "I've got to talk to the guy controlling the plane," and she says, "Sir, the pilot's very busy." He says, "The pilot? God, that would scare me." So, these guys are crammed up in these little towers, controlling the traffic, and it's apparently a pretty high stress job. But I guess I didn't know much about where the origin of it all was, so I learned quite a bit on this. And the origin, oddly enough, was something you probably have heard of, which was SAGE, which was the air defense system. And the Air Force developed that, and the FAA thought, you got to know where all these things are and keep track of which one's which. Well, we need to do that too. So in 1959, they started this integration program with SAGE. And there were a few things that they didn't need. Obviously they're not trying to blow stuff up and things like that. But then there were some other things that they did need. The original people who did SAGE were MIT, and they spun off MITRE, which is where they came from. RAND, who of course, would become Remington Rand with the UNIVAC, and of course IBM. So when they got ready to do the FAA computers, they said, well, IBM actually did all the integration of all this. Let's just go to them. And they had a very interesting architecture where it was a bunch of System 360 computers, which are the big mainframes, the iconic mainframe, the, what would you say, the prototypical mainframe that you see. And they were kind of tied together, but not the way you would necessarily think. It's not just, we've got a communications line going from 1 to 2 and from 2 to 3. They actually had some boxes that were these shared memory boxes. And then the CPUs could all talk to these shared memory elements. And the whole thing taken as a whole was the IBM 9020. And that's what ran the air traffic control system for many, many years, were these, giant arrays of System 360s modified. He had so much detail, and I mean, the post only scratches the surface. So this is one of those, if you just read the post, you're robbing yourself. He was talking about how, if one of the computers went down, the way they would work on it is they basically had a way they could reboot it off of the grid, if you will, and then it was just a normal System 360, and you could do all the normal things you did to troubleshoot those. And then once you figured out, this is what's wrong, you'd reboot it again and join it back into the network of these 360s. And now it's back to the IBM 9020. So it was really an interesting post. I think some of the technical detail was very specific and very interesting, but also just the origin of it coming up through air defense is, I thought, interesting. And another, there's so many cases of military technology driving civilian benefits. It's hard to imagine they would have come up with something that worked as well and as long if they had been trying to do it without a giant military budget that, probably they didn't have. So I thought that was kind of an interesting piece. But the post itself was just beautiful. They really went into a lot of detail and a lot of well-researched stuff about the entire system.
Yeah, and it's a lot of detail, but it's also some very nice writing. So it's a pleasant read. It's probably a long read,
It
Get
is.
yourself a cup of coffee, sit down and enjoy this one. But then you will be treated to sentences like, on the other hand, a 9020 is just 6 to 7 S360 computers married to each other with a vibe that is more duct tape and baling wire than aerospace aluminum and titanium. And it's got a picture of it above, picture of the system above with the different components and stuff. That's an interesting system slash reconfigurable multi-system slash whatever the heck it is. It's like a little computer cluster with a bunch of custom hardware like console controller interfaces. In some ways, it seems to be more of a computer with with an interface overlay than, purpose-built machines, right?
Yes. And, this is actually part two. He has, if you look back last
Oh
year,
no.
yeah, if you look back last year and it's like the first link in the post, he actually talks about air traffic control before that, and it was like, well, they, for a long time, they didn't need air traffic control because there's 20 planes and you just get on the radio and say, hey, I'm landing. And they go, oh, okay, that's fine. And then it kind of progressed from there. And he goes through how when radar started to show up and early air defense, flight service stations, the National Airspace System, and then that kind of led naturally into this part that we were talking about, which was, they started taking Sage and decided to build a, custom solution. But it was interesting too that before they got the 9020 online, different regions of the FAA had their own homegrown computer systems that, of course, didn't work together. So that was kind of interesting that they had done that. And, it's amazing what you could do. Now, granted, I don't even want to think of what that system must have cost with that many 360s in it. I wonder if it's the origin of the old
Exactly.
joke. We used to always say if you sent in the box tops to 10 IBM System 360s, IBM would send you an ASCII to EBCDIC decoder ring. But these guys might have actually been able to get the decoder ring if that was true. So.
Well, my first quick hack comes from Air Barat, the Windows interface you didn't like for Linux. This is a retrofit of the Windows 8, I guess it was called Metro interface for Linux. It's the one that had a bunch of like boxes. Although it was kind of hated at the time, it looks much more like a modern cell phone interface than a computer interface. And that's what Jenny's take is in this lovely write-up. It's a great portable device interface, but an absolutely horrendous desktop interface. Of course, that's what Microsoft was going for with it. They're like, oh, this is going to be our bridging the mobile desktop divide. But nobody wanted the divide bridged.
Well, and nobody wanted the Windows Phone either, which was the other problem.
Oh, yeah. Oh, that's right. Yeah, this is also.
Their world domination of cell phones didn't work out quite the way they planned.
Anyway, if you have nostalgia for this worst of all interfaces, thanks to Air Barat's work, you can now install it on your Linux computer. Next up, typo, binary and digital gradients for telling time. We always have crazy clock builds. This is another one. It's basically a binary clock, except the minutes aren't binary. They just count up regularly, except they do it by glowing in. So the, first 0 to 15 minutes gets brighter, 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 and then the next one lights up for like 15 to 30, and that gets brighter and brighter. But the hours are displayed in binary. It's a really nice looking clock. I don't know how easy it is when you like stare at it to tell what time it is at all, but if you can kind of get a grip on the relative brightnesses, I think it gives you this lovely loose sense of approximate time. as usual on Hackaday, it's a funny new way to display the time. And last up, Retro Game Addict has a demonstration of ordering pizza on the Nintendo Wii again. Apparently, back in the day when the Nintendo Wii had a working network, in Japan at least, there was the Demae channel where you could order things like takeaway food from the comfort of your own Wii console. The Wii network is down, but hackers have reverse engineered it and run their own called Wii Link. And this is an implementation bridging Wii Link over to, I guess it's the Domino's Pizza API with a very Wii looking web page supporting it. And it's absolutely fantastic. You can order a pizza, and thankfully, Domino's will charge you for the pizza when you get there. So they didn't even have to worry about any of the like nasty, complicated payment details. Simple hack and just, a funny thing you could do if you had an open source homebrew Wii network, which nowadays we do.
I guess you eat your pizza and then you use the Wii to work it off. Is that the idea? So my first quick hack this week, Calculator Click has BASIC on a calculator again. So it's interesting, the modern crop of graphing calculators frequently have Python capabilities, and there is a version of BASIC that runs under Python. So what could be better than that? I've actually taken that Python BASIC and put it on some of the Hackaday badges just for fun when we were working on them, and it's actually pretty capable. I think there was some porting issues because obviously the calculator isn't a full desktop PC, and there were some issues, but it seems like it works. It was interesting. He gets all the old all AHL, what was his name? The David All games working. So, if you miss playing Hunt the Wumpus or,
Cool.
All those games that
Heck
were
yeah.
so popular back on the basic computers, now you can run them on your calculator. Jeremy did a little nostalgia piece for us. Robot sees light with no CPU. So if you've ever done beam robotics or a line fowler, this will seem very familiar to you. Essentially he can take a flashlight and lead the robot around because it will follow the light. And of course, nothing much to that. No actual CPUs involved, not even a 555. And last, but certainly not least, ElectroArts has these beautiful looking flux and solder paste dispensers that, if you think of like a clothespin on steroids, that's about what they look like. But it looked like a really cool design, something that would be fairly easy to 3D print and super practical if you work with solder flux and solder paste.
Well, then now it's time for our Can't Miss articles. These are long form pieces written by our fantastic Hackaday writing staff. This week I wanted to pick Tom Nardi's fresh off the presses Skimming Satellites on the Edge of the Atmosphere. And this is one of those questions, it's kind of like the shortest giant or the tallest midget. These are satellites that are so low that they're kind of almost a little bit in the Earth's atmosphere. And for instance, they have to be powered all the time to keep up in orbit because of the drag of the Earth's atmosphere. Why would you do that, you say? Well, there's a number of benefits to having low satellites. One, if you're doing Earth imaging, you can get more resolution because you're closer down to the Earth. And that was the case of the first skimmer satellite that he mentions, ESA's GOCE, Gravity Field and Steady State Ocean Circulation Explorer, which was a gravity measuring probe that was able to measure the surface of the Earth, right? The Earth isn't quite a sphere. It was able to measure changes in elevation of the Earth's geoid and down in the like 2-3 centimeter range. And so it made this like hyper accurate model of the Earth. But the really cool thing is that it did this over a period of 4.5 years by orbiting really low to the Earth with its engines running the whole time. That's the downside of a low orbit and the upside of a low orbit. And the other upside is, of course, that if you have to power it all the time, if it's in the drag of the atmosphere just a little bit, that means its orbit decays a lot faster, which means once the satellite has reached the end of its lifespan, it falls down to Earth and burns up a lot faster. And so you don't have any of the space junk problems in this kind of low skimming orbit because everything that isn't actively powered falls down. And that's a great advantage, actually, kind of counterintuitively, a great advantage of putting your satellites up here. And I think this is something that we'll see a lot more of in the future. I know already people putting up satellites are a lot more conscious of the space junk aspects of it and how to get it deorbited. Here, your deorbiting's free. When you run out of fuel, the thing deorbits. And so that's kind of neat. It's also kind of weird to think of these things as being satellites because, satellites kind of are those things that you throw up there into space and you get them going fast enough that they just kind of spin around the Earth forever. Modulo, little station keeping, and Al, who knows something about space, is going to totally correct me on this. So feel free, man. But the skimmers are they're kind of a different thing. It's high enough up that it can actually be in orbit, like it's actually, being pulled by the Earth's gravity, but because of the friction up there, it still has to be running engines the whole time. So it's kind of, is it a satellite? Is it a plane? It's kind of a hybrid of the both. And the neat thing is that means you have to design a little bit of aerodynamics into it. And some of these satellites look a little bit aerodynamic. And I kind of want to see where this all goes in the future. It's neat because you get all the advantages of being closer to the Earth and you don't have to worry about space junk in your way. So we'll see what happens. I think this is one of those things that, we'll keep our eye out for in the future, and we'll see more than just the two of these skimming satellites we've seen so far.
Yeah, Tom did a great job on this, and the graphics in it are just beautiful. I mean, just
Yeah.
tremendous. I swear that which one is the one, the bottom one, whichever one that bottom one is, SaberSat maybe. I swear I drew that in high school while I should have been paying attention in class, right? I don't know where that notebook is, but I'm sure I drew that. I'm sure I drew
I
that.
think somebody in Star Wars landed on that thing.
Yes, yes. Oh, that's true. Yeah, it does
That's
kind of
the
look like that.
Emperor's shuttle or something.
Exactly.
Yeah.
The other thing I took away from it, which is a total non sequitur, is that Vanguard 1 is still in orbit from
Yeah, right?
1958 and isn't going to leave orbit until 2198. And I'm thinking, we need to go get it. I think somebody should launch a mission to, bring Vanguard home and put it on display at the Smithsonian. I think that's a worthwhile goal.
Space pirates should go up there and take it and sell it to the highest bidder.
There you go. I think what's interesting about this is the idea that it's low or high or anything else. I mean, it is low, but it's not like there's this line that, we have the Kalman line, but that's just made up, right? It's just,
Yeah.
this is space. Why? Because we said it's space. It's kind of like the line between states or countries. Why is that line there? Well, it's because somebody just said that's the line. And we hear that in the popular media all the time when they talk about, the Voyager and Pioneer. Well, it's at the edge of the solar system. Well, what? There's a sign. This is the edge, right? I think that's the thing. It's a spectrum, and obviously operating at different parts of the spectrum require different modalities than operating in other parts of the spectrum. So, for example, if you are building a spacecraft that's in low Earth orbit, regardless of this, there's certain radiation effects that take place. If you are in deep space, it's different radiation effects, so it's not like space is just this, there's this line and you trip into space and then it's space and it's all the same. That's the popular press's issue, is they think there's this, gate, and you open the gate and walk through and, now you're in space. And then I've walked through and I'm out of the solar system. And that's just not how space works. But I do think the low Earth orbit stuff is getting very crowded. I think the lower Earth orbit like this is probably going to have a lot more importance as we start blanketing the sky. There was news, I think today, yesterday, sometime this week, that I guess now other people are saying, wait, we want to have big giant constellations of satellites too,
Yeah.
including the Chinese. And I think Jeff Bezos is planning on putting up more, and he's already put up some. How many giant globe circling satellite constellations can you support before it becomes just, maybe that's how Dyson spheres get built, is just all the Earth satellites merge together and suddenly you have a Dyson sphere. I don't know.
That's how Kessler syndromes get built, is how it is.
You'll have to educate me. What's a
Oh, the Kessler syndrome is the dramatic explosion of one thing that then hits another thing. The bits flying off of one satellite hit the next satellite, which then breaks, and then the bits flying off that one hit the next one, and you get this kind of cascade. And there was speculated to be a certain density of satellites you could have in any kind of, orbital shell. And beyond that, the catastrophic failure of one would lead to a ballooning, and everybody would get blown up. I guess the last advantage of these, what are technically called very low Earth orbits, is that because you do have a little bit of atmosphere, you could maybe think of reusing this atmosphere as, the reaction mass that you throw out the back of the satellite. So far, all of these are ion thrusters, so they come up with a whole bunch of xenon, and then they use the solar cells to charge it up, and they spit it out the back to propel them along. But instead, if you could use that little bit of atmosphere up there and maybe charge it up and push it on through the vehicle, you could use that as the reaction mass, and you wouldn't have to carry up so much fuel. And maybe these could be even crazier cool. This is the Air Breathing Electric Propulsion Proposal, ABEP, and we'll see if that becomes reality. But again, if the rest of the orbits get too crowded and or get full of micro debris, this is going to be the cool place to be, and you're going to want to know how to build satellites that roam around here. So I guess Tom's able to find 2 satellites that have been up there. The Gravity Explorer, and then the Japanese aerospace, JAXA, has a super low altitude test satellite, but it was only up for a few months, whereas the Gravity Explorer ended up being like 4.5 years or something like that. So fairly long run before it ran out of fuel and ended up flying down. But if they can reuse the fuel that's up there and generate the electricity by solar, they could maybe stay up for an even longer time. Cool technology.
That picture I was saying that I'm pretty sure I sketched that in my notebook. That's the air breather, I think.
Artist's conception of the air breather.
Yes, clearly. But yeah, it looks like a ramjet with a shark fin made of solar cells on it. So.
Exact. Bingo.
But yeah, exciting stuff. I don't think we'll be riding on any of that anytime in the near future, though.
No. These are, strictly science.
So I think we should ask the listeners, though, is to propose Vanguard 1 recovery missions. I think we should investigate how to do that.
I think we just set up a GoFundMe and we do it, right?
Oh, there you go. We could have it. It could be the centerpiece at the next SuperCon. Just have come see Vanguard 1.
How much could it possibly cost to send up a little space mission? Go pick it up.
I don't know. That's what I say. We need proposals. What's the cheapest way to get there, attach to it, and get it down without destroying it?
Yeah, we got to get it. That's the problem, is you got to get it down whole, right?
Which, if you had the shuttle or something and you could get it at least to the shuttle, that's fine. But you don't have the shuttle anymore. So you'd have to have some way to, I don't know, encapsulate it in foam and deorbit it, or I don't know. I shouldn't give it away. I don't know. Maybe
this is definitely, it's like the egg drop, but, writ large. It's an awesome Ask Hackaday.
Yep. Self-servingly, my pick this week is by me.
Oh, you're serving us all, Al.
It was another Ask Hackaday, oddly enough. So really, it's not me, it's the commenters. And it was, do you curb shop components? So, I kind of riff on this where when I was a kid, you would go, oh, wow, somebody threw out a stereo or a TV. And so you went and got it, and you spent all your time desoldering these components and, sorting them as though you were ever going to figure out what to do with them anyway. I probably still have a bin somewhere of little resistors with, 1/8 inch leads poking out of them still with some solder on them that I'm never going to use. But it was kind of interesting that, do people still do that? Because A, it's harder to do. B, electronics are not as unreliable as they used to be. So usually when they're junked, they're pretty much junk. And then C, you can order anything you want. It's cheap, kind of like those motors we were talking about at the top of the show. But the comments on this were really interesting, right? So, people were saying, oh, a clothes dryer was out on the curb, but I found out there really wasn't anything interesting in it. Or a lot of people were talking about they like to get microwaves and get the transformers out of them. We've seen several projects of that. A lot of different interesting comments there, and I wonder, it's too bad you can't profile the age of the commenters, but I do wonder how many of those, how many of the dumpster divers are old in my category of old, or how many of them are young. I do think, some people said, oh, I find stuff at Goodwill, but I think one of the things that has really, and maybe in a good way, but one has, quote, ruined, unquote, the used market and stuff like that is the internet, right? So it used to be when I was a kid, you might go to a ham fest and there'd be some guy there who had like a, Tektronix scope that was probably $4,000 new, and he didn't really know what it was, and he just wanted to be rid of it. And he'd let you have it for $15, right? That doesn't happen anymore because nowadays you're going to go look on eBay and you go, oh wow, people pay $250, $300 for those, so you're going to try to get $250 or $300. So I think there's a little bit of that. I think you don't see as much stuff in junk stores because people understand what the value of stuff is. So if it's not junk, they're going to find some other way to get rid of it. And I think even Goodwill pulls out stuff and, offers it online and, in premium stores and things like that. So I think the days of just stumbling over something great that, for $5 is not gone maybe, but I think it's a lot less. I'm always curious, though, you don't hear about a lot of people finding unusual industrial stuff. And so you wonder if the industrial places are just disposing of waste in some responsible way that we no longer can see it, or how much of it is, I wonder how many people see stuff that they don't know what it is because it's not common. So years back, I did a post on the best piece of equipment you're not using, which is thermal wire strippers, right? I have a pair of thermal wire
Oh
strippers
yeah,
that
you
brand
love
new
those.
are $1 trillion. I'm making that up. It's not really $1 trillion, but some big amount of money. And no one generally has those, even though they're fantastic. But if you had never seen one of those before, you could walk right past one of those in a Goodwill and you'd probably think it was some kind of hair removal device or, part of an electric crock pot or something. You wouldn't go, oh, this is something I could use and it's really, really cool. But this is one of those, maybe come for the article, but stay for the comments. There's quite a few interesting stories about either great finds or things you found that you thought were great finds and maybe they weren't as great as you thought. So,
Yeah. It's funny you said that it's harder to desolder things today because in some sense it's easier. Like, you get a board with all surface mount parts on it, you just heat it up and go whack and they all fall off. And then you've got, a horrible mess of random mixed up, half melted to each other surface mount parts that you don't know what they are because they're all unmarked. So, totally useless basically, but hella easy to depopulate.
well, that's true.
That said, do I salvage anything anymore? Probably not. I mean, like you said, everything, the new parts have gotten so cheap that kind of the effective labor cost of doing it yourself means that the parts in question have to be, really valuable. It has to be worth desoldering off the thing. One thing I have had, there was a keyboard that was all the rage for a while, among the online keyboard nerds, because it had these like the 1990s era cherry blacks are like one of these holy grails. And I found a keyboard on eBay, the modern equivalent of the Curb, and desoldered a whole bunch of these. And I actually use them in a keyboard. They're really nice. They're a little heavy, but really nice key switches, and I actually desoldered enough of them that I could use them to run a keyboard. It's a short keyboard; it only uses 48 of them, but whatever. That was a lot of desoldering and kind of miserable, and I probably won't ever do it again. So maybe that answers the question. Microwave oven transformers, I hear that. There are a bunch of like precision elements, like the slidey motion bits in a flatbed scanner are really good if you need something to be, smooth and slidey, right?
But see, that's exactly the point, though, right? That used to be anybody that built robots die to get printers and scanners for that reason. But now with the 3D printers, I get beautiful motion stuff just if I want to pay for it. I mean, granted, but even at the cheap end, I'm getting stuff that's probably better than what I was pulling out of some 20-year-old scanner.
Yeah, for sure. And able to take more load and more robust and yeah, all the above. I
And you know
totally
what it
agree.
is, right?
Motors, is it worth getting motors out? I stole the compressor off of our old fridge before we pitched it. So I've got a compressor in the basement to use for all of my compressing and vacuum needs, which haven't arisen since I pulled it out, and it's still sitting down there.
Well, I don't have this on personal authority, but I do have it on good authority that when there were garbage strikes in New York, people would get rid of their garbage by gift wrapping it and putting it in the back seat of their cars. And that's called gift wrapping the garbage, which of course since has become an idiom for, making somebody think they're getting something good when you're actually passing garbage off on them. But I think that's actually a true story, right? I mean, if you left a wrapped gift in the back of your car, it'd probably be gone. And then, yeah,
I would
it's
not
your
be
garbage.
surprised.
Anyway, so these are some of my favorite kind of Hackaday articles where we really get a lot of stories from the readers, and I think it really made a good one.
Well, that does it for this week's Hackaday podcast. Thanks very much for listening. Show notes, as always, at hackaday.com/podcast. And if you have anything you want us to write up, send us a line, tips@hackaday.com. Until next week.
Keep those hacks coming. You could cut it out. You could cut it out, the first part.
Oh, I wish I could cut it out. I just can't stop.
Well, you shouldn't be shocked that I listened to the podcast. I used to actually sit and drink with Jerry Seinfeld when he was in town, when he was nobody. And of course, I'm sure he would remember me from, a house cat, but that's a long time ago.
What? From the comfort of your own Wii computer.
I'm pretty sure. I think we even covered that. I thought. Maybe not. Isn't there a GitHub with that? Wonder if it says he's got a monkey. Probably not.